Good morning, my dear young friends. I welcome you for seventh lecture of Design of Machine Members 1. So today we will discuss about preferred numbers. Okay, in this preferred numbers, or we can say that preferred series of numbers, we obtained by that geometric progression, and it is going to be rounded off that numbers. So in this preferred numbers, generally when a machine, where we are going to use in this one is when a machine is to be made in several sizes with the different powers or capacities. Okay, it is necessary. It is necessary to decide what capacities will cover certain range efficiently with a minimum number of sizes. So what capacities we have to uh, go for that one? Means we will use different sizes. Okay, when the machine is to be made, generally where we are going to using this one is that when the machine is going to be used several sizes and different powers and capacities, it is necessary to decide what capacities will cover that range and quality range and quality uh, will work minimum number of sizes, that is called as so suppose we are going to using one machine capacity is that say that the power it is going to be produced 8 kilowatt. So in that 8 kilowatt, what we are going to doing, that power we can work any capacity of that uh, machine will work other size of that one. Means we can say that will work efficiency, but minimum number of sizes. So actually that size is required. Suppose we want 50 horsepower. So that another horsepower will be there, 25 horsepower will be there. That horsepower, that machine will work in that plant. Say 50 horsepower required, but we are going to using the 25. So that we are going to giving one number for that capacities, capability, and then that with that machine we are going to taking work over there. Okay, so that is called as a geometric progression. That is called as geometric progression. So in that geometric progression, so here preferred series we are going to preferring. So that numbers we are going to rounding, and we are going to naming that machine. So here that we are naming that machine, that is that preferred series or series of numbers obtained by that geometric progression, and it is rounded off. So generally what earlier also, it is necessary to decide that capacity will cover that certain range efficiently with the minimum number of sizes. So it has shown that it has shown by experience that certain range can be covered efficiently. Means that range should be covered very efficiently and effectively, that minimum number of size of the capacity of that machine. So that's why we are going for preferred numbers. Okay, so that is one of the main important. So these preferred numbers are conventionally rounded off values. So rounded off values they are derived from geometric series of progression, and including integral powers of 10. Integral powers of 10. So integral powers of 10, and it is having that common ratio for solving that common ratio of the factors, common ratio of the factors. What are the common ratio factors? We are going to designate a preferred series, different one. That is 5 series we are going to dividing it. One is fifth root of 10. One is fifth root of 10. That is we are going to saying as that is we are going to saying as R5 series. Another series we are going to saying as R10 series, that is the 10th root of 10, 10th root of 10. Another series is 20th root of 10, 20th root of 10. Another series is 40th root of 10. So this is called as R40 series. Above one is called as R20 series. Above one is called as R20 series. So these ratios are approximately equal to, first we will take R5 series. R5 series, this ratio is approximately equal to 1.58. Okay. And then 1.26, that is R10 series, that is R10 series, that is 1.26. And 20th root of 10, that is designated as R20 series. Okay, that is we are going to saying as 1.26. And then R 40th series, that is we are going to denote it as 40th root of 10, that is R40 series, we are going to getting 1.06. So these series of preferred numbers R5, R10, R20 and R40 series. Okay, the 4 series are called as basic series. These 4 series of numbers we are going to calling as basic series. And then the other series we are going to called as derived series. Other series we are going to called as derived series. So it is maybe obtained by multiplying or dividing basic sizes like 100, etc. So this preferred numbers, R5 are 1, 1.6, 2.5, 4.0, okay, and 6.3 and 6.3. So it is going to be saying as preferred numbers, we are designated, and one code is there. That code name is, according to that code is IS 1076. That is part 1. It is, we are framed this one in this year of 1985. 1985. And we are reframed this preferred numbers in the year of 1990. 1990, we are reframed. Next, generally, this preferred numbers, R5 series is coming under into that. I told it will start from 1, 1, 1.60, 2.50, 2.50, 4, 4.00, 6.30, and 10.00. These are the sizes. These sizes geometrically derived capacities and powers of the machine. Okay, we are designated, but lower powers we are going to using. At the same time, we are attaining that higher design productivity. Higher design productivity. That is that use of the preferred numbers. Another number, we get another series. If you take that another series, that is 1, 1.25, 1.26 part we are taking, and then 2.00, 2.50, and 3.15, and 4.00, and 5.00, and 6.30, 8.00, 10.00, and R20 series 1.00, 1.12, 1.25, 1.40, 1.60, 1.80, 2.00, 2.24, 2.54, 2.80, 3.15, 3.55, 4.00, 4.50, 5.00, 5.60, 6.30, 7.10, 8.00, 9.00, 10.00. So these are that different sizes of the different things. Okay. Now we will see that now what we seen that this preferred numbers basic series according to that IS code 1076 part 1, and we are part 1 in the 1985 it is framed, and after that it is again reframed by 1990. So here preferred numbers for metal products. So this is that preferred numbers for basic series. This is the preferred numbers for metal products according to that IS code 116 and 1136 and 1990. Okay, these are the things. Just you have to mention then that examination. Just you write it this series, and then you can see. Mm. And then just I am going to reading this all these things in series point size range. What is that size range in mm? Size range in mm. So that is 0.012 to 0.10 mm. So that is 0.02, 0.025, 0.030, 0.04, 0.05, 0.06, 0.008, and 0.10. So these are the examples for that preferred numbers. So now we will see that what are that mechanical properties of in when design considerations. So here one more thing we will discuss here in this before completing of this preferred numbers. So we have some definitions. I will speak on this important terms in limits and feeds. So that what is that in limits and feeds? Uh, so some terms will be there. Nominal size, okay, basic size, actual size, limit sizes, allowance, tolerance. So we will see that tolerance, we will see that. What is that tolerance? Tolerance is the difference between upper limit and lower limit of the shaft. Okay, it is the difference between upper limit and lower limit dimensions. In other words, we can say that, it is that maximum permissible size greater than the whole size, greater than the whole size. The tolerance is unidirectional and bilateral. When the tolerance is allowed, nominal size example 20 raised to 0.090, that is the upper limit, and the lower limit is minus 0.004. Then it is said to be unilateral system of tolerance. So here it is that maximum permissible variation in the dimension. Maximum permissible variation in the dimension. That is called as tolerance. So we learned with the help of this preferred numbers. Okay. So once again, I repeat these preferred numbers. These preferred numbers we are going to saying as R5 series, R10 series, and R20 series, and R40 series. Fifth root of 10, 10th root of 10, 20th root of 10, 40th root of 10. Okay, all these things. So now we will see that mechanical properties of materials. What are the mechanical properties of materials? Strength, stiffness, okay, elasticity, plasticity, ductility, brittleness, malleability, toughness, machinability, resilience, creep, fatigue, hardness. Okay, all these things are called as mechanical properties of mechanical properties. So what are the ones again? We will see strength of the rigidity or stiffness, and elasticity, plasticity, ductility, brittleness, malleability, toughness, machinability, resilience, creep, fatigue, and hardness. Okay, all these things will be there. So what are that? Before designing a product, we have to know that mechanical properties of the system. So that's why we are going to learning. So effect of alloying elements. What is this alloying elements? One is that chromium, nickel, manganese, silicon, molybdenum, vanadium. Okay, alloying elements. Chromium, we can mix it nickel, manganese, silicon, molybdenum, vanadium, tungsten. Okay, what are the steels? So we are having that syllabus in that BS steels that is there here. We are discussing steels designation of the basis of mechanical properties. So generally, what is that steel? Steel is these steels are carbon and low alloy steels, where the main criteria in the selection and the inspection of steel is that tensile strength or yield stress. Yield stress. These steels is having carbon percentage and low alloy steels. So where that the main criteria is the selection of the inspection of the steel, we have to test that tensile and mm, as well as yield stress. These two things, tensile strength, we have to test it before going using of this material. So what is that? What is that properties of mechanical? So that strength, flexibility. Okay, strength, flexibility, uh, hardness, fatigue, creep, resilience, machinability, toughness, malleability, brittleness, ductility, plasticity, elasticity, stiffness, strength. All these things we have to um, discuss. Okay, right. So this is that. So whenever we are designing that product, we have to consider, we have to test that yeah, tensile strength of the material. So according to the Indian standards, steels, we are going to designate it by symbol of Fe. Fe. Okay, it is that chemical name. So depending upon whether the steel has been specified on the basis of minimum tensile strength, minimum tensile strength or yield strength. Okay, we have to test it. And we are going to followed by that figure indicating that the minimum tensile strength or yield strength. What is that unit of that strength, tensile? Generally Newton per mm square. So for example, Fe290 means, what is that Fe290 means? A steel is having minimum tensile strength of 290 Newton per mm square. And Fe means that steel is having yield strength of 220 Newton per mm square. So Fe directly we are going to mention means it is a tensile strength. If it is mentioned by that, Fe designation is E, so that is the yield strength. Okay, so that the 290 or 220, it is going to be mentioned. That is the strength, means a tensile strength or yield strength unit. How much it is going to be acting? 1 Newton, how many mm square it is going to be acting? That is Newton per mm square per unit area. How much that force is acting per unit area. Steels designated on the basis of chemical composition, chemical composition. According to that Indian standard, steels are designated in the following order. First thing, figure indicating 100 times the average percentage of the carbon content. Okay, first, that figure is indicating 100 times of the average percentage of carbon content, and we are going to designate it by that letter C, and the figure indicating 10 times the average percentage of manganese content. Okay, manganese content. The figure after multiplying shall be rounded off to the nearest integer. Suppose example you take for this figures. For example, 20C8 means a carbon steel containing 0.15% to that 0.25%. Okay, so what it is going to be meaning that carbon percentage means 0.60 to 0.90%, and 0.8% of an average manganese. So how we are, for example, 20C8 means carbon steel is containing 0.25%. Okay, that is 0.2% an average we are going to taking, and carbon, whereas the carbon is 0.6 to 0.9%, and manganese is there 0.9%. What is that? 0.6 to 0.9 is manganese, and 0.15 to 0.25 is that carbon. So that is that example of that one. So Indian standard designation. So how that we are going to, this is that BS steels. We are having a subtopic BS steels. That is that two examples I discussed, BS steels. So according to that Indian standard, low and medium alloy steel shall be designated in the following order. So figure indicating 100 times of average percentage of carbon, and the chemical symbols will be there for allying elements, each followed by that figure for its average percentage content multiplied by a factor as given below. As given below. So first thing is element, and multiplying factor is different. Element and multiplying factor. See that chromium, cobalt, nickel, manganese, silicon, vanadium will be there. We are going to multiplying by 4. Aluminum, titanium, zirconium, molybdenum. These are chemical formulas. We are going to multiplying by 10. Okay, and nitrogen, sulfur, phosphorus, multiplying by 100. So for example, you take 40 Cr 4 MO, okay, molybdenum. 2 means alloy of steel is having 0.4% of carbon, 1% of chromium, 0.4% of carbon, 1% of chromium, and 0.25% of molybdenum, 0.25% of molybdenum. So here you please clearly observe the example. See, here that multiplying number chromium we are taken, that element we are taken over there. In that element, I am going to multiplying by 4. See that multiplying factor. 40 Cr, okay, 4 MO2 means alloy steel is having average percentage of carbon 0.4 and 1% chromium and 0.25% molybdenum. 0.25% molybdenum. That is that designation. Bureau of Standards designation. Bureau of Standard designations of designations of steel. So, okay, and then we will go next slide. So, Indian standard designation of high-speed tool steel. So, we will see that what is that one? High-speed tool steel. So, Indian standard designation of high-speed tool steel is according to that Indian standard. The high-speed tool steels are designated in the following factor, following articles. What are that? We are going to designate it XT, capital XT. We are going to designate it capital XT. And figure indicating 100 times the percentage of carbon content. 100 times carbon content. And chemical symbol for alloying elements, each followed by the figure for its average percentage content rounded off the nearest integer. First one, letter XT, we are going to denoting, and figure is going to be indicating by 100 times the percentage of carbon content, and the chemical symbol for alloying elements of each followed by that figure for its average percentage content rounded off to the nearest integer. Nearest integer. So that is that chemical symbol to indicate specially added element to attain desired properties is, for example, you take that XT75W, 18Cr, 4V1. So it is, it means that a tool steel is having average carbon content is 0.75%. It is very clear, 0.75%. And tungsten, what is that? Tungsten is 18%. Clearly, we are mentioned over there, 18%. And chromium is 4%. And chromium is 4%. And chromium is 4%. And vanadium is 1%. Again, we will see that in this designation. For example, you take XT75W, 18Cr, 4V1 means the tool steel is having carbon content is 0.75%. 0.75%. And tungsten is, okay, tungsten is 18% and chromium is 4%. And vanadium is 1%. So like this, we are going to denoting XT, letter XT. Okay, so 100 times is the percentage of carbon, whatever we are going to mention first starting one. After that, another one more metal will be there. So another chemical symbol for alloying elements, for each followed by that figures for the average percent content rounded off the nearest integer. It is nearest integer. And chemical symbol is to indicate generally to add that element and to attain that properties and attain to that desired properties. So that is called as this slide is going to be saying as that desired properties, and this entire this designation we can say as Indian Standard, means Bureau of Indian Standard designations of high speed tool steel, high speed tool steel. So here, one more thing we mentioned over here. So for example, I taken here one example, but here two element will be there and as well as multiplying factor will be there. So for example, 40 CR and 4 MO, 2 means alloy steel. This is alloy steel, that is a tool steel. So both are having percentage of 0.4% of carbon, 1% of chromium and 0.25% of molybdenum. Okay. With this, I'm concluding my this video lecture. Okay, thank you.